So today's date is the 28th of April 2026. Time now is 2:01 p.m. So we have to continue what we're working on, Namdi. Plasma. The topic today is called um plasma membranes, application of application, let's call it application of plasma membranes. Application of plasma membranes. So I'm gonna speak from my perspective because that's all I have to speak from. But and there is a way to resolve this matter. What is plasma? What is plasma? Plasma is the fourth state of matter. So you get a solid, a liquid, a gas, and you have a plasma. And plasma. I love plasma. It's not just an existing matter. It's because the probably the early universe had a lot of plasma. Because a lot of them, yes, the early universe had a lot of plasma. Hypothetically, because you got to have a big bang. You know, everything was you got a big crunch, you get a big bang. In my model, but uh, you get the plasma. Which is the idea that you have a system where there's the governance of movement of the in the medium is governed by the forces of interactions. So the force carriers. So if something the system has a force to it, that force is determined by the plasma. What governs the behavior? What dictates the behavior? What dictates the behavior is the force in between the two particles. So they're force carriers. So now let's think of force carriers because that's more quantum physics stuff. For example, you got a solid, which is basically things that are in contact and they have high friction. So you think you get properties like friction, you get properties like but then you get viscosity when you come to liquid. So liquid is really absolutely friction, but for liquid, this a bit spread out more apart. Uh, um, no, and then you get liquid, you get gas. Now, gas is are not viscous. They move out of the way. They have very low friction, and liquids and gases are frictionless. Get no friction in kind of air. You get friction, but you get friction. You get very little friction. In liquid, something but it accumulates over time, so it slows this down because it's still a medium there. But plasma is a fossil matter. I love plasma because plasma is like something you can use for thermal shielding. I won't speak about thermal shielding, just one application of thermal shielding, but I don't really know. So you got like the wind, the airplane turbines, and they are used to ignite turn on a turbine that they'll have to heat up and cool down. Basically they have to charge up. So basically, so it's like they have to withstand the pressure of the whole system, the metal has to system. I'm trying to offer a solution to using plasma. So if you can do this properly, of an engine, you can use a plasma membrane to encounter, so you can have things that are aerodynamic and have no have proportion, but then reroute use the force to carry its own weight. So it's like it's kind of a sci-fi system. It's a science system. It's a science fact system. But I believe it's possible. Hypothetically, it's possible because plasma can sustain the force of thermal shielding. And thermal shielding is just a concept of thermal shielding. It's just a concept of using shielding against thermal force. If you have a turbine and that turbine has an exhaust, and that exhaust carries a lot of forces in one direction, and that it's Plasma is the best bet. I love plasma. So things that exhaust that have exhaust that give out fumes or give out fumes and chemical trails via an exhaustion engine, such as a car, or bike. No, a bike would have to can be modeled as what's the system. Obviously, there's this kind of system called the the six simple systems. Basically, if you take six simple systems and create a plasma membrane, you can have a system that uses plasma to work against the laws laws in that domain. It's like a shortcut. It's advanced. It's like a shortcut because plasma, believe, works on kind of force. The system more uses force to dictate what will interact with. And I can't give you a working problem, but I give you a working problem, and oh my God. Oh, that's me. I'm giving myself a working problem. So by working problem, I mean like the plasma membrane or plasmoid system that uses plasma um to shortcut a solution to exhaustion. Basically, this is what I love plasma. So this is one application of plasma. So you got a turbine engine, and that turbine engine is basically what's used in aerospace engineering. So you can have things that respect the six simple system principles. Like for example, now the six simple systems are lever, lever, pulley, pulley. You have some weight. This is all computable. Pulley system. A lever. You got a weight. Weights. Like a weight on opposing sides of the system. You got a lever, a pulley, what is called a scale, scale, not a weight, a scale, you have this like simple systems. You have a pull and a push. What's that called? A pull and a push. A force acting in one system in one direction, or both. uh Oscillation. But these are all systems. I can't remember how to work them out, but the six simple systems are what we used to calculate, introduce people into elementary physics, so you can see how they can work with systems in the real world via work. So if you go to Geek for Geeks, you can find out how to. If you go to no Geek for Geeks, you go to Guru 99. No, Geek for Geeks. No, Guru 99. No, Khan Academy. You can find out how this works in practice now. Because Khan Academy offers a lot of videos. So I'm saying six simple systems are not really the go there because they were like because they're not they have the same principles. So they are obviously because, I am okay. I don't like thinking about this like this. I'm thinking about simple systems because six simple systems because of a bike follows curvature of X. So I'm claiming, so my hypothesis of the bike theory, the bicycle theory is why bicycles upstrike because they follow curvature of Earth. Every time you pedal, because bicycles are really one of the complicated because you have a system of you got two wheels, but when you pedal it, it stays upright. Why does that happen then? What does that happen when you pedal it and you're a good rider? You have stability. What causes stability? What causes that? That part bicycle was solved by me. I want to solve that bicycle problem. The bicycle problem is the same problem I'm trying to deal with kind of too. So if you have a bicycle and my hypothesis is if the bicycle follows the curvature of the earth, and as you're pedaling, and that pedal of the world generates its own initial has its own initial gravitational pull as a force, it carries a force equal to the gravitational pull of the balance, has a balance of gravitational pull. Given the person's weight, without the person's weight, that's one that's pedaling, that's what bicycle theory is all about. So the bicycle theory is another theory I want to introduce. So it's like is this thing working because of this kind of phenomenon? What's really going here when you put it? Because a bicycle should have three wheels, but you have two. So this is basically the second principles of calculus. Second principle, second the second reason was how it's going to change the change of the system in time and over the curvature to see whether there's a deviation in the law in the specific law. So the third thing I want to discuss here was um, plasmoid encoding. So a plasma carries a force. So that force can be a zodiac vector that means something. So this vector can be written as more formally as a message or something. It can go through a medium and propagate as a wave, as a as a as as a wave of basically basically I'm saying claiming that you can encode messages in forces via plasmoid, plasma system. Similar research uses plasma principles to which are called a plasma system to dictate how cathodes, which are basically positive and negative charge, and ions, something that's positive and negative charge, which is the cathode, behaves when it's not being met by any chemical reaction like an oxidation, which is called an anode. Something that's being oxidized is called an anode. Okay, that's it for today's video. Um, but I really want to start using plasma, to do some of my work. So plasma planes, plasma cars, plasma, because it runs on plasma, plasma energy. You can get some principles, on how it works. I love plasma, so my car will be a plasma car, but using plasma to convert to some kind of form of plasma in the system, so exhaust will be less because the exhaust is taken. I'm not saying this will be less. The same that the exhaust will be there's something in the exhaust. That's basically the plasma is a perception is a membrane that protects the vehicle from deterioration, from kind of being in the inside is basically I'm trying to model it as something that's safe and ergonomic and very practical, efficient. Efficiency. Okay. Thank you for watching this video. 12 minutes. Today's date is the 28th of April, 2026. 2026.